multiply our polynomials together, we have to use the distributive property repeatedly. By this, I mean that what we're going to do is we're going to try to match up term by term the pieces in both the first polynomial and the second polynomial. So if I look over here and I'd like to use the distributive property, I could distribute my 3x to the x squared, to the second 3x, and to our positive 1. So the distributive property would tell me that I need to take 3x, multiply by x squared. I keep my sign, which is addition. I take my 3x and I multiply by my second 3x. I keep my sign, and then I take my 3x and I multiply by our last term, which is the number 1. From here, we know how to multiply monomials, so we can simplify this expression. But what if we have something that's a bit more complicated, like a polynomial with 2 terms and another polynomial with 2 terms? The distributive property says I have to take this and distribute to the x and distribute to the 1. So if we do that, we get x plus 2 is distributed to x. We keep our sign, and x plus 2 is distributed to the number 1. And then from here we do something similar to what we did in our first example, where we distribute our single monomial through the brackets. So now we just distribute in the opposite way. We take x that we distribute to 2, and we distribute to x. And over here we take 1, distribute it to 2, and distribute it to x. Let's go ahead and use the distributive property to multiply out the following 2 examples. In our first example, we have the monomial xy on the outside, and we're going to distribute that through the brackets into the x squared and into our y squared. So we're going to get something that looks like this. We're going to get xy times x squared. We're going to keep our sign, which is the minus sign, and then do xy times y squared. Now we've seen how to add together terms like this in the last chapter. In this term, we're going to have x times x squared, which gives us x to the 1 plus 2, or x to the 3. Since there are no other y's to add powers with, we're left with just y. In our second term, we have y and y squared. We're going to add the powers together to get y to the power of 3. Now I chose this second example because I wanted to show you that it doesn't matter if we have our monomial on the left side or on the right side, we follow the same strategy. So I'm going to take this 2x, which is on the outside of our brackets, and I'm going to distribute it into the 1 and into the other 2x. When we do this, we're going to get our original 2x times another 2x. We're going to keep our sign, which is the plus sign, and then we're going to have 1 multiplied by our 2x. 2x times 2x will give us 4x squared, and 1 times 2x is the same as 2x. So here's our final answer for that second question. Let's work through an example where we are multiplying a binomial by another binomial. Now what I showed you on our first slide was that we can take this first binomial, y plus 2, and we can distribute it to both of the terms in the second binomial. So this might look something like this. Y plus 2, we'll distribute that to y. We keep our sign, which is the plus sign. And then we distribute the y plus 2 to the number 5. From here, what we want to do is we want to distribute once more using our monomials. So in the first term, which is right here, our monomial is y, and we're going to distribute that to both the y and to the 2. In our second term, the monomial is 5, and we'll distribute that to the y and to the 2. So altogether, we'll get y times y plus 2 times y plus y times 5 plus 2 times 5. And we can go ahead and simplify this up. Our first term should be y squared. Then we'll have plus 2y plus 5y. And 2 times 5 gives us 10. Our last step is just to collect together our like terms. We should get 2 plus 5, which is 7y in the middle. And we leave our y squared and 10 at either end. Now I think it's important to stop and look at this particular line just for a minute, because some of you may have learned this distribution in a different way. So what we could do is we could start with our original question of a binomial times a binomial, and we could try to match up every single term. So that means I could match up this y with this y to get y times y. Then I could match up this y with this number 5 to get y times 5. I could match up the number 2 with this y to get 2 times y. And I could match up this 2 with this 5 to get 2 times 5. And that's exactly what we have down here in this starred spot, right? Y times y plus y times 5 plus 2 times y plus 2 times 5. This method that I've shown you in blue is sometimes called the FOIL method for a binomial times a binomial. And really, the FOIL method is just a fancy way of talking about doing two distributions with our polynomials. So whether or not you want to do the FOIL method to get to your final answer, or you want to do a distribution and then a second distribution to get to your final answer, both are completely acceptable to do. Let's finish off the lesson looking at one more complicated example. In this case, we're going to multiply a trinomial and a binomial together. Now, we could either distribute the trinomial into each term of the binomial, or we could distribute the binomial to each term of the trinomial. It doesn't really matter, and it's totally up to your preference. Just to make things look a little bit easier, I'm going to distribute the binomial to all three of our terms inside of the trinomial. When we do this, we get 3b cubed times 6b minus 1. We keep our sign, which is a negative, and we get 5b squared times 6b minus 1. Keep our sign, and we have 7 times 6b minus 1. Now that we've done our first distribution, we can go ahead and do our second distributions. So I'll take the 3b cubed, multiply through like this. When I do that, I get 3b cubed times 6b. And then I'm going to subtract 3b cubed times 1. That's going to be 3b cubed. Our second distribution, we will distribute the negative 5b squared into 6b and into minus 1. So when we do that, we will get negative 5b squared times 6b and negative 5b squared times minus 1. This will be plus 5b squared. And finally, we have one last distribution to do. That's going to be our 7 into 6b and into minus 1. When we do that, we will have plus 7 times 6b and plus 7 times negative 1. That'll give us negative 7. So let's go ahead and multiply through all of our monomials. Our first term over here, we have 3 times 6, which is 18. We have b cubed times b, which will give us b to the power of 4. Here we have 5 times 6, which is 30. And we have b squared times b, which will be b cubed. Inside this term, all we have to do is multiply the 7 and the 6 together to get 42, and we just leave our b as it is, since we don't have any other b's to multiply. And we're almost there. Our last step is just to collect any like terms. There are no other b to the power of 4s, so we'll leave our 18b to the 4 out front. we have negative 3 b cubed minus 30 more b cubed. So that is negative 33 b cubed. And I think that's it for like terms. So we have plus 5b squared plus 42b minus 7. All right, my little epsilons, stay positive.